to keep it as fast as possible. What we're going to do today is simply crack a trial version, crack some sort of verification process for a program that limits the number of days that you can use it without paying, I mean. So anyway, the program itself is called FS Real Weather version 3. It doesn't really matter, but what it does is inject real world weather into flight simulation. Anyway, when I run it, you'll see that it immediately gives me this message: the trial version is over, please buy the full version and enter a key. In other words, if you look at the website of this program, it says that it has a 30-day trial where you can use it without really entering a key. You can see here that it says key was not found. Anyway, if you don't enter a key, you have 30 days of trial until it blocks you from using it. So what we're going to do in general, what's the outline of this cracking process? We're going to look through the executable, we're going to look through the assembly code, the machine code, and we're going to try to find these words, trial version, and sort of reverse engineer, see where this string appears, where literally the address is, where it appears inside the executable, and then we're going to look for some function that looks for this address, that calls for this string. Then we're going to look what jumps into that. We're simply going to go backwards through the code and see where the string gets called from originally, where the entire process of saying that the trial version is over starts. If we find that, then we'll be able to find some kind of if, in other words, some kind of condition or whatever that checks how long it's been, for example, since I first ran the program. That's it. So what are we going to do? First, we're going to use a debugger. It's called X64 debug. You can download it off the internet for free. You can use any other debugger, whatever you want. But the point is, you're going to want to try and use some program that can look through the assembly instructions, so that you can look at it a little bit more feasibly than looking at literally binary opcodes, bytes. Anyway, what we're going to do is we're going to open the executable, FS Real Wex Weather version 3. We open it, and now you're going to see that we have in front of us assembly code. You're also going to notice that it says here ntdll.dll. In other words, there are multiple modules included within this entire program, and we're going to want to look at the main module. We're going to want to look at FS Real Weather and not this DLL that's attached to it, that's baked into it. So we're going to press View, then Modules, and then we're going to select FS Real Weather version 3. Now we're going to look. Now what we're doing here is looking through the main module instead of some other attached module like this DLL. Anyway, this is the machine code, the assembly code that runs the entire program. This is what actually verifies, for example, the trial version, and what eventually loads weather into the simulator and does what the program is intended to do to begin with. So what are we going to look for? As you remember, it gives us this notification saying that the trial version is over. So let's look for that. We're going to right click, enter the menu, and we're going to search for inside the current module for a string reference. So this here is the entire, those are all of the strings that you're going to find inside the program. For example, all the strings that it's going to print out, that it's going to display onto a label, this sort of thing. And we're going to search through this entire list for the words trial version. Now you're going to see that there are a couple of results. The first one and the second one too are, you can see it says here days left. This %1 I assume is related to printf and these kinds of programs, these kinds of functions that format numbers, for example, into a string. Anyway, those two results relate to when the trial version is not over. In other words, they're going to be printed out whenever 30 days have not passed. Anyway, the third result is what we're really looking for, because this, as you can see, is letter for letter the notification we got. The trial version is over. Line break, please buy the full version and enter a key. So what are we going to do? First of all, notice that what we're actually doing here, we're looking at the address where this string occurs. And what this address means, essentially, this is a place in the data segment, at this specific address within the data segment, where the string is baked into the executable. So that whenever you want to, for example, display the string, you refer to that address, and that way you can load the string from within the binary code. Anyway, what are we going to do? We're going to look for the place in the code for the region where this string is called for. So we're going to simply right click onto it and follow it in the disassembler. So we've arrived at this line. This here line, LEA, means load effective address. It's an instruction in assembly. Anyway, you're going to notice that what this line does, it loads effective address, loads what's inside an address, this address, into RCX, which is a register. In other words, it loads the string, which is exactly what lives inside this address, and it loads it into this RCX register. If you want to verify, you can actually look. You can right-click on it, do follow and dump, and then press this to look inside FS Real Weather version 3. And you're going to see here in the dump window the exact string that we were looking for beforehand. The trial version is over, etc. So you're going to notice that in this line, it loads the string, the exact same string that we were following into RCX. Next, what it does, the next line here is essentially calling, it's calling a function, and you can see that it's a function that takes into it two arguments. First, a pointer to character, a constant pointer to character, which means in C a string, essentially. And then there's an integer, meaning this call, what it does is calls some function. It's, by the way, it's called from ASCII helper, but it doesn't really matter. Calls this function, and it inputs into it a string and an integer. As you might guess, what we're actually doing is inputting the string. The string, in other words, the pointer to character, is exactly what happens here. That's the Leah. And the integer comes from this move. And how do I even know that? How do we, and this is this is fancy detective work. You don't even really need to know assembly or C to know what I'm gonna tell you now. Just a random guess. This is literally how I arrived at that conclusion. If you look into this string, this magic string that we looked for, and you count out the characters, you're going to find that there are exactly 73 characters. And if you know C, you're going to know that it's also 0 terminated, so it's actually 74 characters. So the entire notification is exactly 74 characters. And guess what? 4A in hexadecimal is exactly 74. Let's look it up. 4A hexadecimal, and that's it. It's 74. So what you might guess here is that this function eats into it a string and the length of the string, for example, so as to print it out later. This is exactly what, for example, snprintf does, or all sorts of other memory safe functions in C, where you input a string, but also you input a length instead of waiting for a null terminator. Anyway, so the bottom line is this trio, this combination of three instructions, calls some function that uses our message, our magic bad message of the trial version is over. So what are we going to want to do? Again, this is just detective work. This is literally just reverse engineering. You don't really need to understand what's happening here, but the point is this combination calls for some sort of verification. So we want to find what calls this. We want to find where in the code there is a jump into this segment. Now, if I look, let's just randomly look for references to this line. Let's say that I looked for some place in the code that jumped here into this Leah instruction. If we try to do that, if we find references to selected address, we're going to find nothing. Now, that makes sense because at no point did we actually, there is no reason to call this function with only the string. Remember that we have here this full combination of three instructions where there's the call, there's the call, and then there's beforehand the loading of the string, and then beforehand there is the loading of the length of the string, this 4A 74 characters. So if anything, and again this is literally just random detective work, if anything you're going to find inside the bytecode, inside the executable, you're going to find a jump into this move. In other words, you're not going to find a jump into this call or into the Leah. You're going to find a jump into the move. So let's find references to selected address. And guess what? We found one. So let's go into it following disassembler. You're going to notice that in this line here, this exact place in the code, there is a jump back to where we had this string printed out. Um, in other words, if we actually follow the address here, this 039, um, then following this assembler, we're going to get right back to that move and then Leah and then call. So again, we have this jump. This here, this is exactly the magic line that we're looking for. What I mean by that, we have this, again, I'm going to go through what we've done up till now. We looked for where the string that says that the trial version is over looks, where it appears. We looked where it gets called, meaning where it gets loaded into a function so as to get printed or displayed or announced or whatever. And next, we simply found the beginning of the segment. We found where this entire segment of bad verification, failed verification starts. We found the beginning of this segment, and then we looked for some place in the code that jumped to the beginning of the segment, and we found it. This is exactly the line where it happens. And what this means, JG, that's an instruction that means jump greater than. What that means is this instruction is deeply tied to this instruction beforehand, the comparison. What it does is there's this comparison here, and then if the first operand is greater than the second, then this jump greater than occurs. What that means, in other words, is the comparison takes these two arguments, these two operands, and if the first is greater than the second, then jump greater than occurs. If the first is smaller than the second, then it doesn't occur. The point is that there is this comparison and then the jump that is based on it. Now, even more so, if you look at this entire area, and again, I'm still doing detective work, I don't really need to know what's going on here in reality. You're going to notice that there is this call to days 2, and there is this call to current date time etc. You might guess that this instruction checks what time it is, what date and time it is today, and this function checks how many days it is until some date. In other words, we have here a check of what time it is, and then we have here a calculation of how long it's been or how long it might be until the trial is over. So we know that we're in the right vicinity. We know that this segment here verifies whether the trial version is over or whether there's still some time left. Anyway, after this entire date thing, this entire date verification, date calculation, whatever that happens here, we have here this comparison, and it compares EDI, which is a result of all these calculations, and 1F in hexadecimal. And you guessed it, what's 1F in hexadecimal? 31. And 31 is exactly, that's the number of days from which you can no longer use the trial version. We said the trial version was 30 days, right? So what it does here is calculate the date, calculate the difference, meaning how many days it's been since, or how many days it might be until some time. For example, the time that you downloaded, or ran for the first time the program. It takes that time, that number of days that it's been since you first ran the program, compares it to 31, 1F, and if it's greater than 1F, then it jumps to this entire segment that says that the trial version is over, and then it terminates the program and so forth. So we've found beyond any reasonable doubt that this segment, this here, exactly calculates how long it's been since you first ran the program. This checks whether it's been whether it is more than or less than 31. It checks checks the difference with 31, and if that difference is greater than 0, in other words, if the number of days is greater than 31, 1F, then it jumps and terminates the program eventually after screaming that the trial version is over. So what do we need to do? It's very simple. We can leave this comparison as it is. We don't really care about it. All it does is set flags and whatever. We don't really care about what it does. Not in this case, at least. But what we do need to do is take this jump, which takes the detour, which takes us sideways into this termination subprocess, this termination detour, and we simply turn it into no ops, meaning we turn this instruction into nothing, zeros, or 90s, sorry. We fill it into nops. Nops mean no op, no operation. It's simply an instruction that does nothing. It simply continues on to the next one. So we have this comparison, this series of nops that lead to one another, and then this test and another jump and whatever's left. So in other words, what have we done? Again, Um, we've found the area in the code where the number of days since we first ran the program is calculated. Then we found the comparison to 31, in other words, to how long the trial should be. And then we found the jump that is based on it and disabled it, turned it into doing nothing. And that's it. That's all we needed to do. And the crack is done. Next, we're going to patch file. In other words, we're going to export this new executable. Um, let's call it fsrealweather underscore crack, just for the hell of it. Um, and next, let's look at our folder. You're going to find that there's this original executable, and then there's this new one that we created just now that is exactly the same size, same everything, except one single thing, which is this instruction that we changed. Anyway, if we run this crack that we've created, you're going to notice that this time it runs, doesn't terminate, and even more so, it says trial version minus 14 days left. Now you're going to notice that I can download the weather. I can use the program. It's downloading. It's doing everything. The program is fully operable, and in fact, it even tells us how many days we have till the trial is over. Minus 14. It's been 14 days since the trial version should be expired. But after it announces that minus 14, it simply continues running. Why? Because this entire comparison happens, and even you can look at the machine code, you can look at the assembly, and you can find that it in fact prints out this difference, this minus 14. Somewhere inside here, um, specifically here, you can see that there is some form of move, and then you subtract this 31 from however long it's been, and it turns out to be minus 14 eventually. And that's it. We've cracked the program. What do I want? What's the take on this? What's really to be understood, to be learned here? You don't really need to understand too much about C or about assembly or about anything, essentially. All you need is just very general knowledge, for example, of what moves do and what this CMP compare does. You need some basic knowledge, and even more so, you need rudimentary, let's call it even common sense. All I did was simply look for a string that says that the trial version was over, and I simply worked my way backward until I found where the original comparison, the original verification happened, and that's it. I just turned it into nothing. I made the comparison, essentially made it do nothing, made it translate into no jumps at all, just no ops. And that's it. That's how you do it.